Good morning and welcome to OSS News, your source for IC integrity. I'm Mackenzie Ross. In today's breaking news, a hardware verification blunder leads to catastrophe on America's roadways. Earlier this morning, the electronic systems of multiple vehicles on the 405 freeway in Los Angeles were apparently hacked, leading to the longest reported traffic jam in LA history. The cars in question were all manufactured by the car maker MOTOri. This attack bears a striking resemblance to the case reported last year, in which hackers were able to take remote control of Jeep vehicle braking systems. In this special report, we interview an anonymous source, a verification expert from MOTOri who's close to the incident, to find out what went wrong, what is at stake, and how it all could have been avoided. This person has asked to remain anonymous in light of the critical nature of this issue. When did you first realize that this was no ordinary situation? Can you describe the attack for us?
We realized when we first saw the reports from the news come in that the incident was caused by several cars' engine turning off. And when the reports came in that they were all our models, I became very concerned. So I looked into the incident and it turned out that we sent an update to all these models at approximately 5 a.m. and at 6 a.m. Those attacks happened. It turned out that there was a vulnerability in one of our integrated circuits that we used that allowed for the hackers to install a kill switch and turn off those engines.
Is this type of vulnerability common?
Well, to be honest, it is an ever-present danger. I think that many people, even verification engineers, struggle to grasp exactly how crucial this is, and that processors like risc-v, open cores, or commercial ICs are vulnerable to side channel attacks or backdoors, configuration oversights, hardware trojans, and other vulnerabilities. Not only must verification engineers continually hunt down these exposure liabilities, but they must also anticipate far into the future.
This sounds like it could have been much worse.
Oh yes, this would have been catastrophic and potentially deadly.
What sort of things should verification engineers be looking for?
What I would emphasize is that design team must ask themselves some of these questions. Can these protections be bypassed? Are there any extra functions in the design? Can data be injected into the system in order to corrupt that function? And can the secrets be leaked out through some hidden channels? And I believe the formal verification can help answer all these questions.
Is this formal technology available on the market now?
I did a research, and a provider that I would definitely encourage the verification team to check out is OneSpin. Not only do they have the formal technology that can properly address this verification, but they also have what is called gap-free verification that allows the development of executable set of the assertions based on the spec. It also allows proving the mentioned set has no gaps or inconsistencies, and finally proving that the assertions and RTL are functionally equivalent. As a user, you definitely need a sound tools, but you'll also want the knowledge and assistance that personally you need to implement a stringent verification methodology. I would say OneSpin checks all these boxes. And from now on, we at MOTOri will be using OneSpin technology and methods.
Thank you very much for joining us, sir. That's all the time we have. This has been OSS News, your source for IC integrity. We'll see you next time.